let's take a quick look at the schedule. I'll come around and check other homework during class. But the schedule says today we cover section 5.2. Homework due was 5.1. Next class homework is due at 5.2. I just want to point out next week is a funny week because of the Thanksgiving holiday. There are no classes on Thursday or Friday. No classes Thursday or Friday next week. So we will meet Monday and Wednesday, and we won't have class on Friday. Any questions on the calendar? Okay, and just a heads up for what's coming. Monday we have one more section we're going to cover, 5.3. Wednesday next week is our review day. We're just going to go over practice exam problems. Then we'll have the Thanksgiving break, and then right after Thanksgiving break, we take exam 3. So there's going to be a little bit of a disconnect because our class next week, Wednesday, will be the review, and then it's going to be like 5 days before you take the actual exam. It is what it is. All right, so again, we're here on page 225, and we'll start with Lauren. Okay, so let's give this first one a shot. We're going to fill in the blank to show why x squared times x cubed is apparently equal to x to the 5th. Okay, what does x squared really mean at its most fundamental? X times x. What does x cubed really mean? X times x times x. And if I just asked you to write that in some compact way, what would you say? X to the 5th, right? And the exponent is just counting the x's. So why do we have 5 of them? Well, because you had 2 of them, and then you got 3 more of them, and it's 5. Now, in Math 096, which is the intermediate algebra course, which follows this one, you'll see a rule that says, oh, if you have to multiply x to a power times x to another power, what do you do with those powers? Right? You add them together. That is not a rule that I want you to memorize at this moment. I just want you to develop this intuition about that rule, and then it'll be more meaningful next semester when you're given this rule and asked to memorize it. Okay, part B, go ahead and fill in the blank in your groups. Okay, x cubed really means? Good, and then in the middle we have a solitary x, and then another x cubed. And how many x's altogether? 7. Again, there'll be a shortcut next semester. I don't see 7 up here. How did we get 7? I just see 3 and 3. The middle one has a 1 on it. It's invisible, right? And so apparently you get to add all of them together. But again, that's not the goal for right now. Just developing this intuition. Okay, we'll move on to number 2, Morgan. Okay, so go ahead and work through parts A and B with your neighbors, and then we'll come back together and discuss. Okay, taking a quick look at this, x plus x plus x is 3x, no problem. X times x times x is x cubed. In the next row, 2x plus 2x plus 2x is 6x. This is one that stumped some folks initially. 2x times 2x times 2x is 8x cubed. In your head, you need to imagine rearranging. Bring all the 2's to the front, multiply them all together. 2 times 2 times 2, that's the 8. And then all the x's can hang out at the end. X times x times x is x cubed. Good. With your neighbors, do the same thing for number 3. So x cubed plus x cubed, how many of those things do we have? How many copies of x cubed do we have? We have 2 of them, 2x cubed. It's like saying an orange plus another orange is 2 oranges. It's really easy to start thinking about messing with that exponent, to say 2x to the 6th or 2x to the 9th. I mean, we can do a lot of things with those exponents, but if you have an orange and you add another orange, you get 2 oranges. Doesn't change for addition or subtraction. But over here, x cubed really means x times x times x, and then there's another x cubed, x times x times x. Altogether, x to the 6th. I would say that if you write it out, you will never get this wrong. But if you try to use one of these shortcuts that I promise you is coming next semester, you might get it wrong. So I saw a couple of different versions of this answer. I saw 2x cubed. I saw 2x to the 6th, right? If you just write it, you're going to see there's no 2 that pops out anyplace. Okay, down here, this was problematic for several groups. X squared plus x cubed. Cannot be simplified. If you remember playing with the algebra blocks, the x squared was like a square with a little bit of thickness, and the x cubed was a big old cube, and you can't add them up and say that you have 2 of anything. But over here, x squared times x cubed, we can handle that no problem. That's really x to what power? X to the? Everybody up here, I appreciate that you are all working very hard on the blue stuff, but I'm almost done jabbering up here, x to the 5th. All right, so this is important. Everybody listen, please. You can multiply anything that you want. X squared, x cubed, the x's don't care that they have different powers up there. You can multiply them. But addition and subtraction is really picky. You cannot just randomly go around adding up different things and hope that you can combine them. X squared plus x cubed, can't do anything with. X squared times x cubed, no problem. So I'm going to write this. You can multiply anything. Anything. Makes no difference if the powers are the same or different. You can multiply anything. But addition and subtraction is really picky. You can only add or subtract if what's true? If the exponent is the same. That's the only way we can add or subtract. You could add x cubed and x cubed and say, oh, I have 2 of them. You cannot add x squared and x cubed. They're completely different things. You can only add or subtract if you have exactly the same variables raised to exactly the same powers. So as you work through these simplifying examples today, just kind of keep reminding yourself of that basic difference. Multiplication and division, they work really well. You can do anything you want with them. Addition and subtraction is very restricted. Okay, let's see how far we can get in the classwork.